the model items that I'm going to be showing you today are part of Triumph Learning's Performance Coach program. So we hope you will take a look at those materials. However, we'll be focusing more generally on ways that you can recognize good content in the materials you already have, or even improve the content that you already have. We will not be talking today about the value and the role of focus and coherence. Today I just want to focus on the role of rigor. Look at an example from middle school as to what this looks like, namely for a proportional relationship. So if you're given a graph that passes through the origin, we want our students to be able to use the skills of solving the proportion or finding a unit rate and the concept of what makes a proportion in order to solve a problem. So we want all three of those to be interrelated. Okay, another instructional shift is that for different representations of a concept or a skill, they should be linked to each other. So looking at the screen here, the 8 of 6 equal parts is a verbal way of expressing the fractional relationship. The 8/6 is the symbolic way, and we've got a model here that shows the number line representation of the same thing. So is rigor changing in high-stakes assessments? Well, you bet it is. Regardless of what your state test is, they're definitely building high-rigor items. What varies test by test are the item types and the distributions of those item types. So, for example, traditional items, they've been more or less procedural and often focus on one representation of a problem. So here's a typical example where we're looking at fraction addition from a symbolic standpoint, where we're seeing 4 sevenths plus 3 sevenths, and the student has to choose the correct sum. But the problem is entirely symbolic, and if a student can manipulate those symbols and knows how to do that, they're going to get the answer. A newer item might have a procedure, but represent the procedure or the result in a different way. So this would be a more typical item you'd see on a state test now, where the operations being done are presented in a symbolic way, but the result has to be identified within a model. It could be done differently with a different combination of verbal representation. The assessment is also changing the types of items used to assess understanding, just in order to assess all the kinds of connections that students are making within the concepts and skills that they're learning. So the formats that are often used include tech-enhanced items and also paper and pencil versions of these. The formats are not varied just to confuse kids or to kind of keep shuffling things up. They're actually used because they're able to encapsulate a lot of rigor in different ways. For example, the multi-select, matching, and true-false formats that are often used on state tests are intended to test multiple understandings within one particular item. As educators, we often feel we have to stop our instruction for test prep and address the formats that students are going to be grappling with on the state tests or the high-stakes tests in the spring. But it's really the underlying rigor that we have to be more concerned with. So if the fundamental reason is to expose students to the item formats, it's not necessary. It would be necessary to do that at any time of the year. But if it's building greater rigor, there's another way to go about it. And in math, really the way we can support the development of rigor best is to start on day one. Start on day one of the calendar year and focus on it continuously throughout the school year. And really the best way to do that is to build it into everything we do as educators. So embed it in the instruction, include it in the practice, make it part of the assessment. And in the process, we'll be preparing our students for the items that they're going to encounter on their high-stakes test. Okay, let's dive under the hood now and look at some ways we can actually build these kinds of connections. This is a model that's frequently taught in elementary math ed of moving from the concrete stage to the pictorial stage to the symbolic stage. just for a minute, raise your hand if you learned this model in Math Ed. Okay, seriously, I can't see your hand, but I know that there are a lot of you that have seen this and learned this in your Math Ed classes. This model came from the research of Jerome Bruner, and with some of his later research with other colleagues, Bruner and the colleagues developed a different model. It's referred to as the Lesch model after Richard Lesch, that stresses developing not just those 3 levels, but all 5 of these aspects of a concept. And also developing connections between them. So students need to be seeing, for any particular concept, not only what that looks like in terms of pictures, manipulatives, and written symbols, but what the mathematical language is and what the real-life situations embody. And as much as we've been incorporating a lot more mathematical language into our mathematics curriculum and a lot more problem solving, that's come out of the importance of these 5 different representations. So here's how this might look for multiplication. I'm thinking at a 3rd grade level. The real life situation here would be Mike is making 3 trips of 5 miles. And of course we're wondering how far he's going to travel in all. Pictorially, we might be looking at this on a number line, an array, or in groups. The verbal symbols would be the words 3 times 5. The written symbols would be the symbolic form 3 times 5. And the materials we would want them to be able to use would be counters or linking cubes in order to represent that particular situation. Now, this model includes connections in both directions. So if I have an expression like 3 times 5, I want students to be able to show what this looks like on a number line or in a word problem. And that's a little different than what we've been accustomed to historically, where we'll start from a word problem and then learn to represent that as 3 times 5. So the very first tip for all of us as educators is to build connections among different representations of a skill or concept. Okay, now going back again to multiplication and division, then the sorts of things that we're trying to make connections among include 3 different kinds of models: the number line model, an array model, and a group model, and then the 4 other representations that we looked at from that Lesch model. So we've got the 3 different model representations. Okay, how can I build this connection? Let's go back to the Lesch model and look at how to do this for just a minute. So I could represent some real-life situations verbally and see if students can recognize multiplication. So in this case, I'm trying to make a connection between the real-life context and the verbal representation of multiplication. Okay, here's how that might look. Look at the verbal interpretations in each of these contexts. Do they look like multiplication? Well, let's go through them. The first one here, the model train has 8 cars. Each car is 6 inches long. Okay, there we've got a measurement meaning, but that's very definitely multiplication. The second one, Max had 5 shells. He found 7 more. Okay, this is, it's putting a set with another set, but it's addition. The third one involves area, but it's been worded in such a way that if students are looking for key words, they'll not realize that this is an additive situation and not a multiplicative situation. And then the fourth one is a very typical case of sets. So A shows a measurement interpretation, D shows a set interpretation, C is an area situation, but it's not multiplication. So what we've been able to do here is draw a link between real-life situations and the verbal representations. One of the things that we have to take a look at, too, is what connections students are habituated to make and which are new. Because it's important for us to make new connections and not just rely on the ones that they're used to seeing. For example, students are used to connecting the word dividend to a symbolic representation. The word remainder they see as the little r that shows up in a symbolic representation. But what if we were to change this around and ask them to link it to a model instead? To take the verbal representation and link it to a model. What would that look like? Wow. This is not the kind of connection we're used to seeing. But if we want students to identify the remainder, instead of looking for the little r, they need to actually understand the model. They've got place value blocks here, and they've got to see that there's two sets. Each of them has 110 in them and 220 in all. So the divisor is 2, the dividend is 220, and there is no remainder. Okay, this is a very different way of looking at the connection between the terminology for division and models than kids are used to seeing. There are a lot of different fraction models also that we need our students to understand, and they all need to be connected to each other through these different representations. Okay, so let's make some fraction connections, and I think we ought to start by looking at a symbolic representation and seeing what would it look like if we ask students to relate that to a number line model. Again, this is going to be a way of increasing the rigor in the items that we're looking at. Okay, so we can represent it in this way, and by doing so, we also have a chance to check for some misconceptions. This may look at first glance like a multiple choice item, but it's actually a matching item and allows us to actually assess more than one thing. You notice that some of these number lines run from 0 to 1 and some from 0 to 2. So it presents a possibility for us to see if students can handle numbers larger than 1 as well as numbers less than 1. The misconceptions I'm referring to would come out in, for example, choice B here. If a student isn't looking carefully and they see one end of the number line and the other end of the number line and 3/4 of the intervals, they might make the connection between item B and 3/4. Whereas what we want is for them to observe that it's 3 of the 4 jumps between 0 and 1 that represents 3/4. We can also build connections in multiple ways. It doesn't just have to be between two different representations of a particular concept. Okay, what are the 3 kinds of representations that we see here? Take a close look and see if you can pick out which levels are being embodied. Okay, looking at the top here, you're going to see this is a model. It's a strip model of the fractions. In choice A, what we see is the symbolic representation of that addition. And in B and C, we see the language of mathematics being developed. So by having a true-false item, which again is another version of a multi-select, there's an opportunity in an item like this to actually get at 3 different connections that students may be making between the concept of fraction addition and the ways that it's represented. Here again, in this example, there's an opportunity to see if students can recognize different ways to make the connection. Now in this case, it's about different ways to decompose a number. So we're looking at 2 3/10 as a mixed number and looking at ways to break that into a smaller number or smaller numbers. Well, clearly the first 2 are pretty easy to identify. 2 3/10 can be 1 and 1 3/10 or 2 3/10. But if you look at the other choices, you'll see that there are other ways that this fraction, or this mixed number rather, can be broken down that will give us additional insight into what students are understanding. Notice that both D and E are correct. What is happening in D is we're breaking it down into 2 mixed numbers, and in E we're getting at whether students can recognize that a whole number is indeed, in this case, 10/10. So multiple opportunities to get at student understanding here. Okay, what misconception could happen here? If there's a misconception that students often fall prey to, it really helps to have them explain their reasoning. This is a way for us to get at whether they, why they're choosing a particular answer to their question. In this case, the problem involves adding 2/10 and 6/10. The 2/10 is fine, but you see there's actually 5 leaps here. But for a student who's seeing 6 touch points here, 1, 2, 3, 4, 5, 6, and making the error of counting the first one as part of the addition, in the process of them justifying their answer, we're going to get at that misconception. Okay, here we're asking for a whole lot. Students need to interpret, first of all, the visual part that Hank ate. They need to understand the symbolic fraction, and they also need to understand equivalent forms, because each of the fractions that shows up here is not necessarily the simple fraction that's represented up above. So when we look at the actual models that are being joined here or related, we're seeing a strip model in the original example. We're seeing a context in the way that the problem is presented below that. And then we're seeing the symbolic form below that. So there's a whole lot going on here, and this is what I would call an extremely high rigor problem. Okay, here's an example that looks at the concept of fraction scaling in a context. And what I mean by that is one of our standards has to do with the idea that when you multiply a number by a fraction, it either gets larger if that fraction is greater than 1, or it gets smaller if it's less than 1. So what we're doing in this example is asking about comparative sleep times. So we're connecting the symbols of multiplication to the context of sleep time. So if we get to the question, does Angie sleep longer or shorter than Drew, down here, the answer is shorter, because in this case we're multiplying by a number that's less than 1. Okay, so just to summarize, if we're creating items for our students, a great place to start is with building these kinds of connections. But we can also have students make their own representations. And this actually has some advantages over providing the representations for them. And I'll give you some examples of what that looks like. Here's an item that you might typically have seen at some point where the form of the model is provided for the students. So we're asking them to go in and fill in 5 of the 6 parts to show 5, 6. If we redesign that item and provide a grid, rather, to show 5, 6, now the student actually has to make the choice about how to use that grid. So what are some of the different choices students might make? Well, if I have a student who thinks that the 5 represents the part that is shaded and the 6 represents the part that's not shaded, then I may have that student shade in 11 squares here, and that gives me some insight into what the nature of that misunderstanding is. Also, I may have a student that shades in 12 squares here, or picks a grid that's 12 squares large and shades in 10 of them. That would give me an interesting understanding as to how far they've gone with understanding equivalent fractions. Here's another example, and this is the less rigorous form of a problem. We've done a lot of work for the student by providing the model. So if we want them to draw a point 3/4 of the way on the number line, that's not going to be too difficult. But if I redesign that and I give them a number line, and let's suppose I have that number line run from 0 to 2, now a lot of interesting things can happen, because just like what we saw with the earlier example I had, we might see students putting the point at 1.5, or I can see a student putting the point at 3/7, arguing or reasoning that it's going to be 3 units in and 4 still to go to get to 1. So by providing this kind of a grid, we're going to give them a lot more opportunities to show what they don't understand. So third, I think we can have students explain their thinking and justify their conclusions about representations. And we can do this in a lot of different ways. It's a simple precursor task to start out by having kids look at other people's reasoning and just decide, is it sound or not. We can also have students reason about representations by focusing on a particular model to see if they understand that model. So if I've got a model that involves place value blocks, I can put two representations in front of them and see if they can reason about that particular model. Another approach that you can take that's a little more open is to allow students to choose their own model. It gives you the chance to see what model helps them make sense of the problem. So if I'm asking to see whether 5 times 1/2 is greater than 1 or not, I might have a student use a number line model, or it might be more of a part whole model. And the next step you can take is to have students look at other students' reasoning and actually write their analysis of it. So in addition to having students explain their reasoning, you can modify existing items by considering what elements can be changed to ask for a better display. And it's often easier to start with the items you already have and just make them better. So what I'd like to focus on now is how you can modify items to make them better. Start with looking at the context. Can you change it to make it richer in some way? Secondly, can you connect the concept to models? Oftentimes there's a lot of different models you can use. Think about which model you want to connect to, or do you want to allow students to choose their own model? Sometimes the answer that you're looking for has equivalent forms. This is like with the mixed number that we looked at earlier. This is a great time actually to create a multi-select item of one sort or another. And fourth, assessing number sense is a great way to get at whether students are just manipulating symbols or not. Remembering the example we did about comparing sleep times, that's a good example of a number sense item. And lastly, try to stay away from the worn-out connections that students usually see. So now let's take these ideas and let's actually get in and modify an item. Let's get our hands dirty now. Okay, 3 friends share 7 rice cakes equally. Select an equation that represents how much each person receives. Now, what do we see here? Well, we've got a multiple choice item, so that's something I could modify. It tests whether students recognize the divisor. It connects the word problem to the symbolic form. So let's see. If I want to get in and change this problem to improve it, I'm thinking I don't need to give away the numbers in the original problem, and there are equivalent forms of the mixed numbers. So I've got an opportunity to build in an improved context and some equivalent forms of the answer. Okay, so let's look at how we've changed the problem. First of all, I've made it a multi-select answer, and in this way, I can get in the different equivalent forms. So both B and E are correct now. C identifies a common error, and what I've done to change the original context is instead of just having 3 people, I've changed it to Miguel and 2 of his friends. And I think we've all seen where sometimes kids will just pick the 2 and the 7 up and not read the problem carefully. And so some of these other choices that they might make would show that they're not reading the problem carefully. So that's an improvement on that problem that makes it more rigorous. Let's try another way. If I assess number sense, they may need to draw models. So in the process of asking questions, for example, such as whether the number of rice cakes they have is going to be more or less than 2, I'm going to have kids taking a lot of different approaches. So here's the way I've redesigned that problem. Now, again, Miguel and 2 of his friends share 7 rice cakes equally. But the choices now are things like, well, will it be more or less than 1 rice cake? Will it be more than 3 rice cakes? Will each person receive 3 sevens? Does 1 rice cake have to be divided into thirds? So I've improved the context, but I've also assessed number sense here. And one way to assess lots of connections is to write a problem that has several parts. You can use each one to make a connection. So here in part A, I'm having them draw a model. Part B, I can have them write an equation. And in part C, I can actually have them answer the question. Okay, guys, now it's your turn. we're going to take a fairly traditional problem, drawing a model to represent 15 divided by 5 equals 3. And I'm going to give you a few minutes to to see if you can sketch out a possible way of improving on this problem. And remember, think about the 5 different connections that you've got to make. Think about ways you can improve the context. You can include modeling, look at equivalent forms, assess the number sense, or move away from the usual connections. And again, I wouldn't try and do too much with this, but just think about one way that you can improve this particular problem. And we'll come back and look at one possible solution, and then we'll talk about some other things and have time for questions. Please, if you have questions, send them in, and I'll be looking them over. Okay, I know this isn't much time, but I want to get back to looking at this particular item. Here's one of the solutions we came up with. We just changed it to which model represents 15 divided by 5, and have students mark all of them that apply. So this would be a way of comparing the symbolic form to a lot of different models and seeing which of them they understand. It's just fairly simple, straightforward way of improving the rigor of the item. And I bet you guys have come up with a lot of great ways of doing it, which I'm hoping to get a chance to see. But since we're running short in terms of our half hour, we'll stay on after the half hour, but I just want to get back to the key tips, because these are things you absolutely can do. So build connections among the different representations. Have kids make their own representations. Have them explain their thinking, and on your part, modify the existing items you have by considering what elements can be changed to ask for a better display. These are tips that can allow you to improve rigor of items you already have, or to evaluate the rigor of items that are in your materials. So I want to thank you very much. Before you go, if there's any solutions you'd like to send in, you can contact me at my email address right here, jbeers@triumphlearning.com. And I'm going to stay on for a little while to answer any questions. But in addition, I just want to say thanks for joining us today. If anyone wants to stay on, I've got another task for you to rework. I'm going to be staying on for a few more minutes, and we'll be answering questions and talking about ways to change the item. Okay, so this is the second item, and I just want you to think about, it's how many pints are in a half gallon. Think about ways that you could expand the units that we're using here. Think about ways that you could get into number sense by comparing measures. And you can also think about what's a problem-solving situation or application that you could use to get the context connected with the symbolic form here. So I'm going to leave this up for another 10 minutes or so if you guys want to spend some time working on this, and then we'll just talk briefly about solutions. And in the meantime, if you have any questions, I'll chat while you're working in the background. Okay, one of the questions that's come in is, what's the greatest way language arts teachers can support a math teacher? I'm thinking an explanation. Anything else? One of the things that is a key element of the standards of mathematical practice is precision. And one of the things that we want to focus on in all of our language study is precision. So just for example, when students are providing answers to problems, oftentimes they think if the problem was stated contextually, it's okay to just ask or answer the question as 8. What we want is for our students to be constantly going back to the original question they have, whether it's a language arts question or whether it's a math question, and making sure that the answer they provide is something that answers that question. It's a consistent point for English language arts or for math. So the answer isn't 8, it's 8 pints, or it's 8 inches, or it's something else. But to get kids to think about whether the language that they're using explicitly addresses the question that was asked. Do you think that these expanded rigor makes for good cooperative learning activities? I absolutely do. I think that the more complex the situation gets, the more kids are able to work together, and oftentimes they have, one student may have an approach that another student hasn't thought of. So when I was talking about the different models that students use, you're going to find that some students are very facile with, let's say, a number line model, and maybe other students are not. So in the process of working together, those students have an opportunity to explain to each other the way that they would approach a problem, and in the process, they're learning from each other ways of thinking about those connections that they otherwise might not see. I think cooperative learning is a great environment in which students can help each other make these explicit connections. How do we support the type of thinking, this type of thinking for children who are coming up way below grade level, especially with the big shift in the Common Core? Yeah, that's a great question. That is a great question. All these are great questions. I think that that one of the things that we have to do is arm our students with more and more tools for them to be able to make these connections. So for students that are struggling below grade level, I think that the best way to do that is to arm them with a lot of different ways of representing a problem. Let me give you an example. If I am asking a 4th grader about a canoe trip, and I say, we've got 32 kids going on a field trip, and I'm going to make that a little easier. Let's say 18 kids going on a canoe trip, and the canoes only hold 3. How many canoes are we going to need? It's going to be a real asset to a student if they can't solve that symbolically, if they can solve it pictorially. In other words, if they can construct a model that actually shows the canoes holding 3, and then figure out how many canoes they're actually going to have to build in order to accommodate the 18 people who are going on the trip. So the more we can enlarge the tools that they have in terms of the models they're working with, the better able they're going to be to handle a variety of different kinds of problems. Okay, we're getting toward the end of our time. I think I'm going to head back to the question we had earlier, how many pints in a half gallon? You guys have probably come up with some great ideas here. Here's one that we worked on here at Triumph Learning. What we did is compare measurements to 2 quarts. So we took a number sense approach here and write the measurements in the correct box. So we said let's set up a context, but let's also use different kinds of units. So we had gallons and cups, pints, and we're comparing them to quarts, and we had them sort them as to whether they were less than 2 quarts, equal to 2 quarts, or more than 2 quarts. So, you know, again, this is a case where we're having them work with equivalent forms of units, where we didn't explicitly bring in models, but we did improve the context, and we put a lot of number sense in here. I think you guys have probably come up with some great examples as well. And just in concluding, I'm going to back up because I want to leave my name up on the screen. And if any of you have ideas or questions you want to send in, please send them in, and I'll be happy to get back to you. So that's going to wrap things up for this afternoon. Thank you all for coming, and I hope you enjoyed it.